Good morning. My name is Manuel San Emeterio and I work for ERNACT. We are part of the Data2Sustain consortium. That is the European Digital Innovation Hub, where this workshop is being organized. I also want to welcome our partners from the ERNACT project. We have here people from Sweden, Finland, Iceland, and also the Irish partners. We thought that this was also a very good opportunity for them to participate and to see what are the possibilities and what are the services that we are offering to companies and public sector organizations in the northwest part of Ireland and as part of the European Digital Innovation Hub. We have a really good panel of presenters. I'm not going to extend myself more. We are going to start with Mike Conroy. Mike Conroy is the director of the Data2Sustain EDIH. He has a lot of experience and has held multiple global engineering VP and Ireland site leader positions in 3 United States multinationals in the tech industry for more than 20 years. He's currently a member of IT's Enterprise Digital Advisory Forum and a board member of former chair of ITAE Innovation and Technology Atlantic Gateway. So Mike will let us know more about Data2Sustain EDIHs, the services we offer. So Mike, the floor is yours.
Thank you, Jose Manuel. You can hear me okay?
Yes, perfect. Thank you.
Okay. First of all, apologies. I'd hoped to be in the room and circumstances conspired against it with some other events, so apologies for that. In the interest of time, I'll go very quickly. There's some really excellent people in the room there. In the WiSAR team and in ERNACT who can go into a lot of the specifics around the opportunities around the European Digital Innovation Hubs and the type of companies we're working with. So in the interest of time, I'll press ahead. Again, welcome to our sort of European colleagues who are in the room, and hope you have a good visit. And so let me, there's obviously a mixed audience. So for, as Jose Manuel said, the EDIH Data2Sustain is a consortium of the two universities in the west and northwest, University of Galway, and it's led by the Atlantic Technology University over 9 campuses, but also includes ERNACT and in its leadership in sort of public technology and digital transformation programs, in addition to a lot of the agencies. So broadly speaking, where the European Digital Innovation Hub fit from a national perspective, there are 4 digital innovation hubs. They were launched last year. They're set up to run for the next 3 years. 2 Factory Exchange and CEDAR, quite specialist on Industry 4.0 and operations and sustainability. CEDAR is focused on artificial intelligence. Data2Sustain is focused across all sectors, with probably an emphasis on sustainability. And Entire in the south of the country is focused on a range. It is part of a broader European network, and I think the opportunity with all the European Digital Innovation Hubs is the sort of visibility and interactions that can happen across applied technology in the digital transformation area. In summary, if you were to pick 5 points, the objective is to support organizations to adopt technology and embrace advanced technology to be more competitive. It's a fully funded service, so the funding is already in place within the consortium or within the institutions, and it's passed on to clients directly via de minimis state aid. And that can be to implement projects up to 100,000 in value, typically. So it's really, there's an element of one-stop shop, accessing expertise and infrastructure in a flexible fashion, more flexible perhaps than other mechanisms allowed. But also extremely importantly, it's really quite interlocked with the agencies. We are working closely with the Leo network, Údarás na Gaeltachta, who are a steering member, Enterprise Ireland, and we try to interlock our engagement with companies in conjunction with the agencies, which might be to get to a starting point to get a company off the ground with a prototype. It might be to bridge between until sort of commercial supports kick in. It could be to work with the company and other parties within the consortium to enable other sources of revenue. And also importantly, it's kind of multi-service, so you can combine a combination of some business services coupled with some technology, perhaps coupled with some user experience, to take an example. So they're probably the main differentiator in terms of why you think the EDIHs are useful to companies. I'm going to go reasonably quickly through these folks in the interest of time, getting into the meat of things. I kind of see it fits at this intersection between the agencies and the business support organizations, the public RDI, of which WiSAR is one of the most significant and impactful applied innovation teams, and the commercial IT services world, and the services kind of fit between Test and Best, which is an innovation classic innovation service around building prototypes and getting to pre-commercial launch, pre-commercial engagement with clients. But it's very flexible around bringing groups together. For example, we have a group together today around a particular topic between public and private, and so we can use the funds to advance those in the interests of the parties, either commercial, public sector, or the RDI community. And also there's obviously a skills and business impact. So I'll push on. The technologies are flexible, so it really is a question of matchmaking between published services and companies. And unsurprisingly, it covers broad digitalization, but also into the engineering side of things in terms of architecture, software, and the data management and AI, and obviously the topic of today, IoT. But obviously, IoT is in a full stack context, it covers all of those. The emphasis is, as said there, companies are eligible up to 3,000 staff. There is an emphasis, obviously, on smaller to mid-sized companies in terms of their innovation roadmap. But eligibility is up to 3,000 staff globally, not in Ireland. They must have an Irish registration, and also public services, public bodies or companies limited by guarantee are also eligible under certain criteria. I'm going to keep pressing ahead. So what we try to do is work across the groups, partnering with people like Stephen and Sean, who are in the room there, to kind of develop services development on top of expertise that's been created over many years, and then combine that with perhaps the core team that's been hired, or with other expertise, sometimes of a domain or sectoral specific. So obviously today we're sort of focused on particular sectors as well. So it's kind of a classic combination. And then we help to bring groups together through events, workshops, working groups, and kind of sustaining those conversations to kind of get to innovation projects and then fund those. As I said, this is obviously a pretty kind of the kitchen sink type chart, but there's nothing within our EDH or working with the other EDIHs that prevents us sort of addressing any particular sector. That's not necessarily the case, obviously, with traditional RDI, which is typically focused on exporting our service sectors in certain aspects, but this allows a broader reach in terms of, for example, tourism, retail, construction, and technologies like that advances the digital maturity of a company. When you put it all in one picture, ATU, you're in Donegal today, people in the room. It's one of 9 locations, ranging from farming, piloting locations to marine to tourism. So a very diverse set of innovation centers, which we bring all together and combine some of the digital data technology aspects of the consortium, perhaps with some of the more domain and application sector centric. We tend to hopefully see some more. And then we have some other partners that we are starting to work with, like, for example, where I am today, the AM Centre in Sligo, Futurecast, which is around construction, but then also linked with some of the national bodies like Irish Manufacturing Research. And as I get to the finish, typically today we have the services that exist. You can go on the website, you can go and take a look at what they price. Ultimately, it's a discussion. You figure out how to get those, and they can be approved very quickly. They're essentially approved between the Data2Sustain leadership, which is sort of me, the service group, for example, in this case, WiSAR as an example, and the client. It's not subject to any other agency review. But many cases we find ourselves in conversations where exploring how to create new opportunities that are quite bespoke, and then perhaps repeat those for other companies. When you go on the website, you can't see this. You'll see these type of services. When you go a little bit deeper, you can kind of go into each service and get an idea as a starting point for that conversation. Like I said, we try to add to those as we go. We've been working with various companies over the last 9 months across a range of subjects. That the people in the room, which you there from WiSAR, have been super active on a number of these. and can talk to them in detail. But they do range from quite a few of them have I would call an IoT theme in its broadest sense in terms of media and data analysis and applications. So with that, apologies if I ran a little bit, but we can get these slides around later. I'll answer any questions an hour later, but I think you're well served in the room for people who've got questions.
Thank you very much, Mike. So yeah, now that you know more or less what is Data2Sustain, what the services can be offered, can be accessible for SMEs and public sector organizations, we are going to enter now into the topic that we are covering today. So the workshop today is about Internet of Things technologies, and also we will have the opportunity to see potential applications coming from very good providers, and also some experiences that have been implemented by local authorities, like it is the case of Donegal County Council. So we are going to enter into the topic before forgetting for the people online and also for the people that is in the room. After the presentations, we will have the opportunity to get your questions, and there will be a Q&A session. So please, the ones that are online, please leave your questions in the chat. We will be going through them after the presentations. And also the ones here, if you have questions, you will have the opportunity to ask the speakers. So our second speaker and the first one in relation to the topic is Dr. Seawright. He is the head of the manager of the head of the WiSAR Technology Gateway here at the Atlantic Technological University. For the ones that you don't know, WiSAR is an applied research center for Internet of Things solutions for companies in Ireland. Stephen is an entrepreneur in residence at Catalyst, the leading Northern Ireland manager of incubation space and entrepreneurship networks in the region. His career has been spent in new product development and commercialization. His previous experience includes being co-founder and CEO of Security Limit, leading the company from its inception to product introduction. He was also commercial director of Benetel, a telecom and wireless design consultancy, member of the executive board for the Japanese multinational TDK Electronics Europe, and also CEO of TDK in Ireland. So, Stephen, the floor is yours. Stephen is going to show us some of the work related to IoT and expertise that we have here at WiSAR at the Technology Gateway.
Okay, nice to meet you all. Thanks for coming here today. For those of you who have been funded by government grants, you're familiar with the fact that we have to have all of these logos at the bottom. So we are currently funded through European ERDF funding. I'd like to start with giving you some introduction about what IoT is. Most of you are probably familiar, but just a couple of slides. Then talk about IoT networks and maybe a recent innovation around that you may or may not be familiar with. And then I'll give you an example of an IoT implementation that we have done. Some conclusions there. I think I've got 15 minutes. So about us, as Manuel mentioned there, we're an applied R&D center. Applied R&D means, I suppose, it's another euphemism for product development or helping companies along in their development journey rather than doing research that leads to publications. So we do practical things. We're called a gateway because companies can come to our office. We tend to do projects with engineers who are embedded into the Atlantic Technological University WiSAR Lab, and that's in the corridor to my left. So you're welcome to have a look after this morning's workshop. But also we dip into resources into the faculty of engineering technology. That might be research, active academics, and perhaps even their postgraduate students. I also have a small group in TU Dublin and in the RF Centre there at the EMI. So then on the Internet of Things, I think it might have been Cisco came up with this. If you're a software person, you know, and software, we always talk about software stacks. Things are obviously going to be in some smart person manages up to 7 layers for IoT. So starting at the bottom layer, there you've got the physical layer. That's the electronics or the sensors or whatever that's physically gathering the data. They have to be connected to the cloud. So the second layer there is the connectivity layer, the wireless network, typically, but of course you could have a wired network getting information up as well. Occasionally then push on edge computing. That means that the device is collecting the data and can have some smarts inside it to maybe store information temporarily or process it or reduce the data size before it goes up to the cloud. So it's two and three are kind of together there. When it gets to the cloud, you're gathering the data together, you're putting it into a database, you're organizing it in fashion that you can use it. Level 4 or layer 4. In 5, that's where you're taking that data, you're extracting it, and you're making use of it. This then leads you on to an application layer where you might have apps or dashboards, things like that. And very top layer there is where you're making money. If you're a company, you're making money out of the whole process. So with that in mind, so therefore it's all about data collection at the bottom and delivery to the cloud, sorting it out, visualization. Okay. So I'd like to just mention part of this, the network part. LP1 is well, first of all, there's all be familiar with cellular networks, 4G, 5G, even Wi-Fi. They would be all typically networks that are helping you, in this context, gather data, pick it up to where you want it to go. But there are some IoT specific networks that are available. One category is called low power wide area networks, LP1. Comes in a few different flavors. But then all of these LP1 networks are optimized for the process of gathering small amounts of data from sensors and bringing them onto the cloud. So it's not about streaming video or even audio. It's small amounts of data. So I said here, think Twitter size messages, but that's more than enough for many sensor type applications. There's 3 major types. In the room, anyway, on the right hand side is the cellular type technology. There's actually a few more flavors, but one of the main ones is called narrowband IoT, and it piggybacks on the 4G network for IoT type applications. On the other side, you've got Figure4. That's a dedicated IoT network. So it's a business model that's similar to a cellular type network. So you pay for your data, you pay for a subscription, that sort of thing. Right in the middle, you've got LoRa, and it is an open standard, so you can make your own LoRa network. They all, on the closed side, you can contact all 3 technologies. They have very long ranges, so that can be somewhere between 5 kilometers. We've done some tests with Sigfox where we could actually get signals 40 kilometers away, and that also translates into if you can send over data over a long distance, like over the sea or whatever, then you can maybe get 1 kilometer in an urban environment where there's lots of obstacles in the way. And all 3 technologies have very low power consumption, so the battery will last quite a while. Of course, it depends how often you're using the battery, so it's somewhere between 1 year and 10 years. And as I said, on the negative side, it's a low data and infrequent communications. So just in terms of comparing LoRa then with cellular, I'll not dwell on this too long. The big thing about LoRa is it's a private network. So once you've got it up and running, you've got low operational costs, which could be important for a public sector context where you get a capital investment, but you need to sort of make sure that your ongoing costs are low. Cellular, of course, is a big advantage. I would say is the quality of service. And this is because the cellular companies, they put in these big bids to license spectrum. That means that RF channel they're using is theirs. Nobody else can interfere with it. And they can manage that, and they've got great management ways to do that. So it's a managed network. You don't have the crowding that you can have with LoRa. But theoretically, with LoRa, it operates in an unlicensed band, and also not going to be all technical on you. But you can imagine if you've got lots of LoRa devices, and you really have an awful lot of LoRa devices, they are all trying to send information from themselves, from these little devices, to the base station. We call them gateways at the same time. Theoretically, those packets, those bits of information can collide, and some of them may, and therefore the quality of service is less than you would get in a cellular network. So that's the downside. But nevertheless, this LoRa technology has been getting a lot of interest in recent years. Just to give you an idea of the costs, I'll be giving you an example. We used a simple single channel indoor gateway, and that costs about 150 euros. An 8-channel equivalent is around about 400 euros. So single channel, you might be able to have but not all devices are not communicating at the same time, and therefore you can still have maybe a dozen devices communicating to that one gateway. Obviously, then if you've got more devices you want to have more channels available. And then the one on the right is an example of an outdoor base station. So if you're in the room, we can show you our outdoor gateway, which is on our roof here. So that gateway is up there. It's configured so that anybody can use it. So it's open access to it. So a hobbyist could be down the road developing a sensor, and he can connect to the cloud through this curling gateway on the roof. Some applications that you see, I tried to pick ones that are kind of public sector type ones. Waste management, a level sensor that goes into a bin. People counting and tourism. In agriculture, a common one we see is a desire to monitor the soil moisture to understand if a piece of land needs to be watered. So that can, in a public sector context, that could go into looking at flower beds or that. Air quality, I think Daragh might be speaking about that, I'm not sure. But even in a lovely environment like Donegal here, where we've got great air quality, that can be a good thing to advertise, and you can compare your excellent air quality maybe to an urban environment. Utility companies were some of the first companies that adopted this LPWAN technology, because if you think about it, especially in Europe, the meters, water meters, electric meters, gas meters, they're often in cellars or very difficult to get at locations. So from getting the information out from an RF point of view, this technology that takes us time to send the data works. Especially if you go to a country like Italy, you'll find that they use they have wireless means of collecting information from water metering. If you're from Ireland in retail, you'd be very familiar with going into an Apple Green or other retail outlets, and you see little happy or littles. I'm happy today, or am I sad today? Yeah. So that is using this LPWAN technology to send a little simple message, happy, sad, whatever. Car parking. I noticed one of my colleagues, I thought he might have been here today. These occupancy centres, they work by putting a sensor underneath the car, so the car goes over it, and the sensor detects that there's a car in the car park space. The car goes away, the sensor then communicates to say car park is now available. My colleague, our farm colleague, I say, has a startup where he's looking at how to do something similar to that, but more in an open car park environment, and he has some smart ideas around that. And the last one is monitoring people or fall detection with assisted living. So the one thing I want to kind of bring to your attention this morning is a new type of LoRa network that has been started probably 2 years ago and is becoming quite popular. So if you consider the standard cellular infrastructure, 3 or Vodafone or You can imagine that they have had decades of getting coverage across the country. So traditionally, the LoRa implementations meant that you weren't guaranteed, or it was quite patchy in terms of getting coverage with LoRa. So, okay, we have a base station here, so there's some coverage around Letterkenny here for LoRa. And in order to improve that situation, people needed to be incentivized to buy LoRa base stations or gateways and put them up. And particularly when we're looking in a public sector context, you know, that's an important thing. Secondly, they also, that incentivization also means that if there's a way to monetize your investment in a base station, then you're incentivized to keep it going. You want it to pay for itself. So the Helium network is established, and it's a LoRaWAN network comprised of hotspots that provide the public network coverage. And in return, people who put up their own LoRa gateway, or these hotspots as they call on Helium, they get rewarded. They get rewarded in a cryptocurrency called HNT. Now, you don't need to be enrolled in that cryptocurrency side of things to use the network. You know, I can develop and operationalize a LoRa device, and then as long as it's compliant with this particular Helium network, it can communicate with that. But the people who then put up the gateway and this hotspot behind the gateway, they are essentially paid for each transaction that goes through there. It has people can read that later, I'm kind of going off script probably, but it has a secondary important feature in that each hotspot has an understanding of exactly where it is. And the blockchain or the crypto idea there means that that particular location is verified and is continuously verified. So that means that you are in a situation where it's possible then to use this Helium LoRa network for tracking items across the network. And that was one of the things that couldn't really be done with a traditional LoRa network. So one interesting example here is a TrackPack sticker. And so it's a very low profile sticker that you can put onto a box or any item. And this can be tracked over the LoRa Helium network. With a 3-volt 600 milliamp hour thin cell lithium manganese battery. So these are very flat batteries that look like thin film capacitors actually. It can last between 1 year, up to 1 year. There's caveats with that. So if there are any engineers or people interested in technology who are interested in looking into this further, there's a link there where you can download all of the design files, the PCB files, the firmware, and give it a go yourself. 1 minute. Oh, there. I'm sorry. I was going to give you an example. So, WiSAR Lab, our main job is for companies. So I don't have lots of public sector examples since that's at random time. Maybe that's a good thing. But the example I've tried to give here is one that uses 3 Data2Sustain services. So a prototype development, a UX design for an app, and the implementation of that app. This company we've worked with for a while. They do microscale anaerobic digesters. So any LP1 system, for example, LoRa, is useful for 2 things. The first one is the one that we're probably all thinking of, which is collecting data. But it can also be used for process control. In other words, you're telling the apparatus, you're gathering the information and then you're feeding control information back to change behavior or whatever. In this case, we developed a control board, which is monitoring temperature sensors and also then controlling valves and switches over this quite complex system. The first project there is the development of this control board. In this diagram, I'm showing the control board and the antenna port down at the bottom, right-hand side of the PCB, communicating to the LoRa gateway. It's then connected to the cloud either with Ethernet or 4G. Then send the information to, in this case, to the Things network server. It could also be the Helium network server. What that does is it takes the information in the device and says, okay, this device is telling me that it wants to be routed to AWS or to Azure or to somewhere like that. So I'm just going to put us through that. That then led on to a dashboard. It's the client's dashboard, so they can see what's going on. And then inside this dashboard, he also has the mechanism then to control remotely that control board. Turn on files, to turn on switches, to put it into hibernation, etc. We then have a second project is a user interface design. First step of that is scoping out how the app might look. So doing things on whiteboards, stickers, and so forth. Establishing what each of the pages in the app might look like. And then moving into we talk about a low fidelity prototype, but it's a sketch to you and I. So just drawing things. So this work was done by the guys from our graphic design department here in ATU. After that, then we have mid fidelity prototyping using a package called Sigma, so that would be black and white. And then the third step is we do a high fidelity prototype, so you're developing all of the artistic stuff, the colors, the logos, etc. Then the third step is for us to take that information and to use it to develop an app. So in this test before Invest and Data2Sustain, we don't develop commercial apps. This is a progressive web app, so it's an app that will work on a mobile phone. It will also scale to a tablet or work on a PC. It just doesn't use all the smarts that we would find inside a modern day mobile phone. So it's not looking at the GPS. It's not looking at the accelerometers and stuff like that. We're simply using the screen function of the phone. And the nice thing is today we were able to take the output from the graphic designer's package, which is called Figma, and use some AI to speed up the software development process of that, which is interesting in itself. So we get a leg up when we speed up this process. And so the result then is an app on the left-hand side, a couple of screenshots from the app, and a dashboard for the user as well. So that somebody who buys that system can see, has some level of control over it, and can also see how it's going. My eyes aren't good enough to actually see this, but in the middle screen you can see today's results. It's 3 kilograms of food waste were processed, 240 litre rates of biogas production, 12 kilogram carbon offset, and so I kind of completely skipped about what the application is, but the application is these big eggs. Or you could, so on the behind the egg is a macerator where you dump your food waste in. That's crunched down, ends up going into this big egg, which breaks the food waste down into gas and some liquid offshoot, which can be used for fertilizer for your garden or whatever. So this company we've worked with over a couple of years. The guy left his public sector job and he went for it. We developed all of the electronics and software around it, but he's a specialist in understanding waste management. And he and his wife then were successful in getting investment at the end of last year. They won an award in 2023, at the end of 2023, and they now are shipping the first products. And they're finding their main traction in the public sector, especially around schools, universities that have canteens. Yeah. I think that's okay. Yeah. All right. Thank you. Thank you. Thank you, Stephen.
Thank you, Stephen, for presenting us all the possibilities that the technology can offer. And as you were saying, we have this expertise here in WiSAR that is available. In particular, today we are targeting public sector organizations, of course, also SMEs. So now we are going for our next speaker, our next presentation. He's going to cover more the angle from a local authority implementing this type of solutions. So we have here Daragh McDonough. He's now the acting head of information systems at the Donegal County Council. And Daragh has been working for the council for more than 35 years. And at this time, he has driven an innovation approach to information systems. He's a GIS project leader, and he has developed a best-in-class mapping system and online map portal that I want you to recommend to visit because it's very informative. As broadband officer, he has laid out the digital agenda in the county on things like the rollout of the national broadband plan, developing the network of digital hubs and innovative ICT projects. He's also participating and managing the European funded projects related to technology, like the ERNACT project. We have partners here implementing disruptive technologies, and actually, in your case, you are implementing some IoT solutions, artificial intelligence like enabler and civic tech engagement tool, digital tools for the participation of citizens. So Daragh, the floor is yours. Please try to speak to the 15 minutes. Thank you.
Good Manuel. Road Letterkenny. This Gurmagad Happen Curl, Larry and Shaw in New, we Hidgelin the Nari, especially as the Court Funday. Good morning. Welcome to Letterkenny, and thank you for the invite to speak here today about our experience of Internet of Things and the County Council. I just thought it was appropriate to start off with a bit of Irish because ERNACT are up for an award in business through Irish, the local chamber awards next month. So best of luck with that. Anyway, so let's move on. Margaret put down the title as Rivers, Roads and More, I think. So we'll go through in that order. I'm the broadband officer for the County Council, as well as other roles, but as part of that broadband role, we have to sort of promote digital transformation. Nigel here as well from Sligo doing the same sort of work in Sligo. So look, it's not all about the National Broadband Plan, but it's how do we use that, how do we maximise connectivity for other projects. So one stage, a number of years back, we went to the Digital Hub in Donegal. That was our first experience of Internet of Things in a sort of a lab settings where we actually could hold sensors and see the results and dashboards and all of that. The department at that time had a funding program for these sort of innovative projects. So as you can imagine, Donegal down here in the southwest coast, and it's a 6-hour drive home to Letterkenny. In that 6 hours, myself and my colleague developed a project proposal using Internet of Things and the County Council. So that's where it all started. So today, that experience we've had, I'll chat a little bit about the good and the bad and the ugly side of IoT as we see it somewhat. So we'll start with rivers. We have a requirement to monitor river levels on the River Finn. It's the largest river in Donegal, frequently floods during the winter and affects some of the towns on the river system. At the moment, there's only one sort of state monitoring station in Malbafay. That's the main town. It's great. It gives fantastic data, but it just tells us what's happening in the town at that particular time. What we wanted to know, could we monitor the river levels upstream to see what's coming down the river to hit the town, later on? Or is it still rising? Is it starting to fall? So you get a more dynamic sort of information about a flooding event. Could we calculate the flood flow stream downstream? How quickly does a flood move down the system by looking at the peak at different locations down the river? And then getting an understanding of how this river catchment reacts to rainfall. Could we monitor the tidal conditions? Lifford, the river in Lifford is tidal, and how does that affect the flooding that comes down and hits the tide coming in? You know, give you an idea of when more water will be able to go out. Or in Donegal Town, where we have issues around the car park flooding when the tide is particularly high. So monitoring all these sort of information in real time gives us better management information and functionality. So the whole thing where we had to look at where could we strategically place sensors on our own infrastructure to make it as easy as possible. So like bridges, but are the bridges in the right place? Are they above or below confluences? So all these questions, you know, when you think, oh, I'll do an IoT project, and then you get into the nitty-gritty realities of, oh crikey, where do I put the sensors, and does it make sense? Because we don't want to end up collecting data for the sake of collecting data. It has to be meaningful and it has to be useful. So if we move on to roads, again, could we monitor roads that are more susceptible to frost conditions in the winter? Because we run a big winter management plan here in Donegal. And could we bring that information into winter? Again, we have 5 roadside temperature gauges, but they're not on, you know, the high roads. They're not in the middle of the county. So again, could we get more sort of granular information? Again, could we mount them on our own infrastructure? So we didn't want to be going out building anything new. So did we have road signs available to us, existing poles, that sort of thing? As Stephen mentioned, this could we monitor traffic and pedestrians at key tourism sites? Again, it's about knowing quantitatively how many people are going to a site. We don't want anecdotal information anymore. We want actual evidence. And this also feeds into the environmental impact of tourism. So quantifying that impact, knowing how many pedestrians, how much traffic is coming into an area. Our tourism sort of approach was always get the people in, get more people in, get more people in. Now it's more about managing that in an environmentally sensitive way. So you need to know the figures. Again, some of these tourism sites are in hard to reach places like mountains, walking trails, that sort of thing. Could we put sensors in to monitor those areas? Again, as Stephen mentioned, air quality. We implemented air quality sensors in towns that were based on a Wi-Fi network. They worked in the office, and when we put them out on site, they didn't work. So again, a bit of the bad or the ugly side of IoT. And then could we share this data with fault charts? We were capturing all this data. And another part of that process is to share it, contribute to the greater good. So Fault Ireland helped us with funding, and we give them data that they never had before, like actual numbers of their key sort of Wild Atlantic Way sites. Just a few myths around IoT as well that we've sort of come across. Myth number 1, IoT is cheap. Not cheap. As an alternative to, the state-of-the-art sensors, it is cheap. Okay, but you need to factor in installation costs, third-party vendor costs, the data hosting costs, sensor replacement costs. And what we found is you need a budget, you don't need a fund to implement an IoT strategy. And fund will only get you so far, but then how do you keep that service going? And that's where the likes of ourselves need to implement these sort of budgets now to manage this approach to data gathering. So you have to think the cost of the sensor might be cheap, but then there's a network charge. And Stephen mentioned like narrowband IoT. It can be expensive enough, you know, especially when you scale up your number of sensors. And the installation cost was the big charge cost that hit us in some of our pilot projects. I'll show you some of our data hubs and visualization analysis cost, replacement cost, plus they will break, and installation costs. Just to give you an idea of why I say IoT is not cheap, that sensor there, we put to monitor pedestrians. It was going into wild areas, so we needed it to be waterproof. It was IP68 rated. They came in at about €1,500 each, something like that. They are sealed devices, so we couldn't replace the battery. When the battery died, the sensor was useless. So that was an expensive cost. And the battery life did not last as long as the marketing material said it did. 3, whoops. Okay, 2, it's easy to install. Health and safety takes care of that myth. It's not easy. How do you put a sensor on a bridge that's over water? You have to hire in a device like this that will cantilever the worker rate over the bridge safely, and you know they're tied in, working above water. This thing comes from Cork, and as soon as it leaves the yard, they start charging. This is James and myself carried these posts, the sensor, 2 bags of postcrete, spades, crowbars, half enough sleep league to put one in. It nearly killed us. Real-time data is easy to set up. There are limitations in coverage. You know, we were looking at trying to put sensors up into the mountains, you know, hard to reach areas. There was no coverage there. So there was no Sigfox, there was no narrowband IoT. We weren't really looking at LoRa at that time. So, you know, there are limitations that you need to adjust just for. API integration can be different. The data can be very complex coming from a sensor. So some API integration is easy, some of it's not. Visualizing that data can be tricky enough as well. As I mentioned earlier, battery life is never as long as it's advertised. Again, it depends on the environmental conditions, things like that. The sustainability of, you know, replacing sensors when they die, or I think that pedestrian sensor wasn't very sustainable since it was a once-off use. And this was a road temperature sensor that we put in, so it looks like a camera pointing down on the road, reading temperature. There it is. There it is gone. Somebody stole it. And we looked at the data and wondered, why is this temperature just staying the same? 15 degrees for weeks. We went out and had a look, and it was gone. Somebody had taken it and obviously put it somewhere, still communicating. Fortunately, we didn't have a GPS sensor in the device, so we never got it back. Another one was just smashed off the sign. But this is the transmitter for the water level sensor. They started to corrode and they started to leak, and they all just died on us. But saying all that, we still got really good data. This was traffic using a radar sensor, and it was able to classify the traffic coming in and out of these tourist sites. So we got an idea of many cars, how many vans, how many lorries or motorhomes and that sort of stuff. And you can see, the profile of traffic over a year there at one particular site. So, really, really good information. This was the road temperature information over a couple of days in the winter. And again, really, really good information. So you can see when it dipped below freezing, how the road engineers then could use that information. This is showing the battery life of that pedestrian sensor. So you can see it report back the battery life. And there was days it just dropped. So it was beginning to fail and then just went off coverage. So 1 minute. And this is the water level on one of the rivers. Again, every 15 minutes you were getting a water level. You can see when it floods, it rises really quickly and then just drops off. Really, really good information. Again, visualizing that information, these were the pedestrian counters. Again, you could look at monthly numbers, daily numbers, or hourly numbers. And it gave the site managers better oversight of when people were coming on the busy months. Very, very useful information. They found it really, really useful. And then, just to finish off, when you suddenly realize your sensor is not sending you back any information is going on here, never underestimate the public's creative use of a sensor. This one in Malin-Head did the report for a couple of weeks on what's going on. Some of them finally decorated it in a Christmas hat and just couldn't communicate out through whatever is going on. So that's just a whistle-stop tour of some of the IoT experience we've had in the county. We've learned a lot that we take into the next sort of implementation of IoT and what we're doing in Atlantis with the ERNACT project. So I hope you enjoyed that. Thank you.
Thank you very much, Daragh. Actually, I think your presentation was really good, covering not only the nice thing, but also pros and cons. I don't want to open here a big debate because we don't have the time, but what I think is true is that, especially with the public sector, is there's an increasing demand for evidence-based decisions, evidence-based data. So this is where I think that here Internet of Things can have an important impact. The other thing is that, of course, there are all those installations and maintenance, but we have also to think, and again, I don't want to open the debate, but we have to think what are the alternatives to get then those data. Probably is not sending a person in a harsh condition, you know what I mean? So I think, of course, is where you have to put everything in the balance and to see, because I believe that there's still these type of technologies bring advantages to the purpose that they are thought about. Okay, thank you very much. Our next presentation, I think, is going to be our presenter being online. Sean Noon. Sean, are you there? I hope so. Sean is the CEO of WiSAR Technology and experts in the design and manufacturing of controls, time clocks, and smart city devices for road, street, and outdoor lighting. The company founders have unrivaled experience in street lighting controls, having served the street lighting industry since 1982, so more than 40 years now, in the design and manufacture of these products. The company now has an install base of over 7 million streetlights across Europe, North and South America, Canada, South Africa, Australia, and New Zealand. So you have a very big footprint. With this strength and commitment to research and development, the company is building up its catalog of smart IoT city products. So, Sean, thank you very much for being with us today. So, the floor or the screen or the network is yours.
Good morning. Hope you can see my screen at your side.
Yeah, can see it on the Teams at least.
Yeah, can you see me? Yeah.
John, I can see it on the Teams event. I think in the room they're just getting it organized.
Okay, that's good.
John, we can't see your video in case you wanted to do video.
Yeah, you should.
Go ahead, so it's okay.
Okay,
Yeah.
there you go.
Are we okay? Good morning, everybody, and thank you for inviting me to do this presentation. And sincere apologies for not being able to make it to Letterkenny. I wasn't able to do that today. I could do it next week, but that's another week. Some problem here. My talk today is street lighting is ideal foundation for creating smart areas. And first of all, I'd like to introduce our company. WiSAR Technology, we design, manufacture the world's leading lighting controls and accessories for the exterior lighting industry. And we've registered the trademark Fit and Forget because we sell products that you don't really have to replace. It's a 100% Irish-owned company, supported by Donegal County Enterprise Ireland, and they look after us pretty well. The company, myself and my colleague Jerome that founded the company, we've been in the industry for a long time. So between the two of us, we've over 70 years experience in the design and manufacture of photocells and various types of lighting control products. And as your previous introduction mentioned, we've over 7 million street lights under our watchful eye across the world. And that's a quick look into our factory. We've automated our production. It's state of the art. And why street lighting? And why is street lighting ideal for developing smart IoT cities? First of all, it's ubiquitous. As it's wherever there are people, there's going to be street lights. And they provide an extensive network of connectivity. There's one street light every 30 meters, and they have an energy supply, as you will see in your own towns and cities. The street poles, along with the luminaire canopy photocell, can support a wide range of various smart IoT technologies. Street lights in our towns and in our cities, we see them as natural hubs for big data collection, and most importantly, for environmental data collection. Using the street lights reduces costs, environmental impact, and it helps us accelerate the rollout of smart cities. We don't have to build a new infrastructure. It's there already. It's do nothing 12 hours of the day until the dusk comes when the lighting is switched on. So streetlights are ideally placed for monitoring traffic. They're ideally placed for monitoring the weather, the air quality, the citizens' movement and the vehicle movement. Installing, retrofitting, maintenance and upgrading of the nodes and sensors is cost effective and very simple. It can be done during the maintenance of the street lighting installation itself. Our system is quite simple. It's a smart photocell node and a gateway. The earlier presentations were of interest because we fit in pretty smartly with the earlier two speakers and the problems they have and how we can solve them. This photocell node fits on top of the canopy of the street light. it interfaces with the LED driver, and the LED driver nowadays in the streetlight is very smart. It communicates on the DALI2 D4I protocol. We not alone is it a photocell, it's also the communication means for getting the information back to the platform. It acts as a photocell, and it's important that a photocell switches streetlights on and off. So therefore, we've taken the precaution of including an astral clock and a light sensor to make sure that no matter what happens, that streetlight comes on at dusk and goes off in the morning. Each of the photocell nodes can be updated over the air. They have their own GPS on board, power meters, and that's critical because we want to monitor the energy used by the streetlight and whatever is connected to the streetlight installation. Cybersecurity hardware is on board, and we operate the photocells in a mesh network, and they communicate with each other, and then they communicate with a reliable link back to the gateway. The gateway device sits in a strategic location, and it communicates with 150 of those photocell nodes. So it consolidates the data from each photocell node, transfers it either by Wi-Fi or cellular to the remote servers for upload to the platform. It's open, it's interoperable platform. It connects with all other smart IoT cities that's in your town or in your city. And you can see there on the left-hand side the range of different sensors that we can communicate with. And I think that's important because smart cities cannot be rolled out using just one company. It has to be a partnership of cooperating partners to roll out a smart city in any town or city. So what's really important about our system is it delivers adaptive lighting. And you say, why adaptive lighting? This October, a new range of standards has been, it comes into force in Europe. Almost, I think it's about 9 standards that's dealing with all aspects of street lighting and ensuring that not alone are street lights saving energy, but that we're also saving light. So you have standards introduced so that adaptive lighting can be adopted, where traffic volume is measured dependent on the weather conditions. The road surface, then to give us a minimum dimming performance so that we can save energy. And you can see here on this slide where how adaptive dimming works. It all depends on the traffic flow, the weather conditions, the road illuminance itself. So all of that's been measured and sent back into the platform, and the dimming takes place in sync with the conditions that's to be experienced on the road itself. So to be on the street and to monitor and deliver information off the street, we have to make sure that it's very secure, because we have seen the past what happens with hackers. So every single one of the photocell nodes that we supply has a built-in security measure. We like to try and ensure that any data that's collected stays in the country that it's collected in. So in each node is an encrypted application-specific processor, and that's soldered into the PCB board that ensures that that node is 100% secure and that's fitted into every streetlight. And I think that's critical when you want to roll out smart IoT cities. And we make use of a mesh network rather than a star network. And the reason we make use of a mesh network is that each single streetlight is secure. If the gateway goes down, then it's not going to affect the streetlight installation. The streetlights are going to operate as they did in the evening before. If it was a star network, then if the gateway went down, then all the streetlights would go down, or if, as we've seen earlier, what can happen, say the gateway was damaged when faulty or whatever. So we have to be very secure that, seeing that we're going to use the municipality's streetlights, we have to ensure that those streetlights switch on when they're supposed to switch on and switch off when they're supposed to switch off. It's a plug and play, easy to install system, because I think the most important thing about any product or any system is that it's easy to install. It's we say as we market the product that it's as easy to install as changing a light bulb, and the deployment is rapid. For example, with a past product, a smart grid photocell, we were able to install about 6,000 of them in the one month in Florida in the United States, and this system would be exactly the same. The infrastructure is existing, so we don't have to build a new infrastructure there in your towns, in your cities. Every 30 meters, as I mentioned earlier, there's a street light. And the installation and operation is cost effective, and we heard the other speaker mention about how expensive IoT devices can be. Now we're able to say here this morning that this is very cost effective. It's interoperable and it supports a wide range of smart city sensors. And it doesn't matter who owns the sensors. We will work with the companies that own the sensors and cooperate with them, and they can use that platform, if it's deployed in your town or city, to get their information back to the cloud. It's scalable and easy to add new technologies. And most importantly, which I think is very important, it's user-friendly. And you can see here on this slide how it works. Smart photocell sits on top of the streetlight luminaire canopy. It communicates back to the gateway. 150 of those smart photocells communicates to one gateway, and that gateway communicates either through 5G or whatever back to the cloud or back to your own server, and then it's visualized on the front end of your either a laptop, desktop, or mobile phone if you have a mobile phone. And the communication, we look at all aspects of communication that's active in a town or in a city, whether work with the mobile phone operators. If it's LoRaWAN, and we had to talk earlier about LoRa, we work with whatever means of communication is active in that particular city. We can work with that with those companies. Reporting and alerting are not only provided by email. We can provide by email, but we can also export in every moment the latest status of the full installation, and we can do that in many open formats. Might be the reporting on the environment. As you can see here, streetlights are ideal for reporting on the environment. So we can measure pressure, humidity, whatever is needed to be done in the environment, and that information can be reported back to the platform. And the weather station may not be owned by us, it may be owned by other companies. And as I mentioned earlier, the secret to developing a successful smart IoT city is for a number of cooperation partners rolling out these type of devices to be able to work together and then work with the platform provider, which we would be hope to be the platform provider. Data reporting, so we can report from any type of sensor that's utilized within the town and city, and that's to report back information that delivers information that's good for the municipality and for the citizens. It may be as flood warnings, air pollution, particles in the air, and there's many dangerous particles in the air. CO2 emissions from various sources, non-board weather station that can be mounted on the street pole that sends back warnings of snow, ice, the temperature, climate trends, flood risks and warnings. Monitoring the traffic, sending back information for town planning data that's essential. Checking the water quality, it's what type of pollutants, and that's all coming back from the various sensors that's deployed in the city. It could be smart bins, and in some installations in Europe, we have information coming back about the heat variation that's in that particular city, and sometimes the municipality needs to know that. Maybe traffic.
So we have 1 minute more, okay? Thank you very much.
It may be traffic measurement, how many vehicles traveling in particular part of the city or town in an hour, so on. Traffic flow reporting. I'll just go through these slides fast, and in these slides I'll just demo some of the successful examples we have of the platform operating in various towns and cities. And in Malaysia, we proved quite clearly that we saved them 859 megawatts of energy, because it's not just dimming the streetlights, it's dynamically dimming the streetlights in sync with the weather and with the traffic flow. And here's another installation we worked on in Germany, and this was a renewable energy installation, so our platform is ideal where solar is implied as well. Here's another installation again where we saved over 75% of the energy, and that's after them replacing the old HID lamps with LED street lighting, and then we came along again and saved them an additional amount of energy. So that's by talk. I hope it was interesting, and any questions I'll be delighted to answer. Sometimes I find it easier to be able to get the information across when you have good questions.
Thank you. Thank you very much. It's very impressive all the work you're doing. I think you touched very important points, like, for example, interoperability, because if a public sector organization, for example, goes for this type of investments, it's important that they are not stick to a particular technology or a vendor or a provider, and then they can build up the network aggregating solutions like your solutions that are interoperable with many different technologies. So yeah, we have, if people have more questions, we will have them after our last presentation. We have Kira here, Kira O'Brien. Sorry for my pronunciation. He's the CEO of Semicom. And first, I really want to appreciate that you are here with us. You made the effort to be here with us, Kira. He's an engineering graduate of UCD Dublin, and Kira began to work in research and development electronics engineer with Emerson Electric Company in St. Louis, in USA, focused on the development of electronic motor drives for home appliances. Then after that, he moved to Italy to lead an engineering team in ASTI developing electronic motor that drives for major domestic appliances. In 1997, still in Italy, he became director of the Emerson division developing electronic controls for diverse range of kitchen appliances. And then 2001, Kieran moved back to Ireland to set up M Semicon, where the focus has been on the development and supply of electronic controls for multiple sectors, especially in IoT and MLD. And I guess, Kieran, you are going to talk us or to present us more about your audience. Thank you very much.
Okay, thank you all for doing the invitation to come and speak to you today. It's a pleasure to come up here and meet you all. So just a brief overview of our company, what we do. We're based in Dublin. We do electronic product development. So we're the sensors, the hardware. We develop the physical piece that starts where the data comes from. We develop our own products and also products for third parties. We're very active in the IoT space for the last maybe 10 years or so. We're also, just I mentioned, we're also involved in some European funded projects of our own, mainly in energy and electronics in general. So that's kind of who we are. There's some pictures of some of the products that we've developed over the years. That white one down there is an LED device, light basically. This is audio board, HVAC. That's the heating control, and some medical boards. But anyway, so in our IoT portfolio, we've been working on some products in particular. I've picked out a few of them just to talk about today in the context of how they might, how their use might improve or does improve services for citizens. Again, that's one of the focuses of the public sector. So they are the waste bins. Some of these were mentioned before, so forgive me if there's a bit of repetition here. Flood detection is a big theme here. In fact, down in Cork the last couple of days, it's been a big problem. Water safety, that's rainbow detection, and energy monitoring. So anyway, just to look at the practical aspects. Most towns and also in rural areas and beaches and lakes and so on, there are a lot of public waste bins like that, and it costs a lot to go collect them. The normal thing is that you go there, every day or every 2 days, whatever it is, on your scheduled collection. But some, quite often they're not all full. Some of them are, you don't know when some of them fill up. Some of them fill up every day, some only occasionally. So it makes sense to. It would be great to know when they're full, or more to the point when they're not full. So you know not to go there and collect them. So a collection on a day that it's not full is a cost, whereas a collection or a failed collection when it is actually full is also a bad service. So trying to find the compromise can be solved by using IoT. Sorry again, this is repetition here, but just what we talk about in IoT. This IoT can mean anything: your phone, your smart TV. All these things are IoT devices, but here we're talking about IoT in the sense of sensors that are run by batteries, usually out in the open, measuring something. That's the context of today's discussion. So on the left, we have our sensor there. That particular one measures distance and is used in a bin. It communicates via radio, which could be any of those networks mentioned already, through the network that's provided usually by third parties to the cloud, and in the cloud, all those other steps 3 to 7 of that table that was presented earlier on by Stephen, I think. Yeah, that's where all that stuff happens. All the data is analyzed and so on, and presented to the user in the form of apps and suggestions of what to do. So anyway, the case for monitoring. Now, if you read the literature, those promoting sensors and so on will tell you that 50 to 70% of collections could be removed. I'm not so sure it's quite that high. Our own experience is more like 20 to 40%. If you do the analysis, if you do the measurements and so on. But yeah, again, you don't need a monitor on every device. If a bin fills up every day anyway, there's no point in putting a monitor on it. It's an extra cost, extra data costs, extra installation costs, all those things. So, one needs to look at that. Sometimes you don't need a sensor. Sometimes you could just have it as a data point there, but not actually physically install one. Put the sensors on those devices that really do need them. Yeah, so anyway. So anyway, the benefit for the user, this is where the focus is. A lot of people think, well, we're trying to reduce costs, make it more efficient. But actually, on a practical level, the studies that we've been doing, the real objective was to add more bins. The council wants to add more bins. There are new estates out there, they want bins. But the council has the same staff, the same number of lorries, the same resources. So the way to do that is just to be more efficient with the ones that you're actually collecting. And that's where the IoT comes in. You retain the staff, use the same resource, but you have more bins to collect. Rather than doing unnecessary collections, you do maybe half one day, half another day, when they're required. So that's the objective. Yeah, this concept we call it virtual monitor. Other people have different names, but if you have a situation where you have sensors on some assets but not on others, then you end up with two different databases that are not related. But what we do is we create these virtual monitors. These are data points. Like the blue dots there are not real monitors. They're bins. They're on the system, but they're recorded. So you can go there and record data. With your app, you can go there physically, find me the bin. It'll find it automatically using GPS. And if there's something to report, like it's broken or the lock is broken or it's knocked over or whatever, you put the data in, which is into the same database as the information that's coming in the bins themselves. So that's what you pull out as integrated together without actually having the cost of a monitor everywhere. So, okay, another one, flooding, I say, is very topical. We've been working, this is the first IoT product actually, was a gully monitor. Flooding can be lots of forms. You can have small flooding. It could be irritating stuff where the road is just half full of water because the gully is blocked. Or more sinister reason is this what's called surcharging. Water's coming back up through the pipes, raining somewhere else. And that's very dangerous because it happens very quickly. So we developed a sensor to detect this condition here. So again. Yes, so again, not all gullies need these. I mean, the estimate in Dublin City Council area is around 1 to 3%, I believe, have this problem, a serious problem that they regularly get blocked. Now they have their own policy where they just keep cleaning them out all the time, but sometimes that's not enough, and they still want to know what's going on. So that's again, of course, this also detects flooding in general. You can repurpose this thing to detect a road flood anywhere and get that information back. So, see, yeah, here's some examples there. And leaves, a desperate problem. You can have a condition here where the leaves you can see them. I've seen them on, it's raining and there's a bunch of leaves just floating down the road and it just stops on top of a gully. Water goes down. Then if it rains again on top of those leaves and a car drives on them, it creates like a paper mache cover over the gully. So it's another condition. It's a road. I took that picture in Connemara there a few years ago. It's a road that regularly floods, so it would be great to have a little sensor on that to send the signal back, 2 or 3 kilometers down the road, so traffic knows that the road is blocked. It's another example of where IoT could be used. That's what the sensor looks like. Yeah. Now, this is the challenge. Somebody mentioned the cost of the sensors themselves, how, Daragh mentioned this, the real life, literally at the coalface here, when you're putting these sensors in these locations, some of them are desperately difficult. It's not surprising that the water level on the river didn't last, because it's just some of these are really, really difficult to deal with. This is a typical, well, not typical, they're not all quite this bad, but this is the inside of a gully. It's horrendous, This is electronics now, so you're trying to get a signal out of what is almost a Faraday cage as well. It's a big iron box. Trying to get a radio signal out is not ideal. It's very dirty, temperature extremes, very cold, very hot. That's what you're dealing with, okay? So, unfortunately, in a case like this, you don't need to report very often. Not like a bin, for example, where you're reporting every day. These maybe only when it floods, and then you send out a so-called heartbeat say I'm alive, you know, still working. Yeah, mitigating local flooding. So anyway, just guess what I've said already. Just knowing when there's flooding is great. You do something about it. You can send out the team there to unblock the gullies or deal with flooding danger before it actually causes a problem. Again, that's improving citizens' life. Yeah. So yeah, water safety is another. You need to deploy these around Dublin and Dublin City and in the port as well. These are a big problem. Is that people take these ring buoys, so-called, or life buoys, and they throw them into the river. They even steal the whole cases, the big yellow cases, and I don't know why they do it, but that's a real problem. One night there, the night that the COVID restrictions ended 2 years ago, 3 years ago, 8 ring buoys disappeared on one night. You know, just people having fun. So, but detecting that, support that they be there because they're there for a reason. So, again, IoT can be used for that. You have a sensor. There's actually a sensor on that. It's very hard to see, but a little, very discreet black unit there detects if the ring buoy is gone missing and reports that. So again, the improvement for the citizen is that you've got greater safety there. Also, again, in a rural context, I don't know how often Donegal, for example, checks the presence of ring buoys out on the west coast, but I'm sure it's a fairly expensive operation to send somebody up all the way over there. So the benefit of IoT in the case of that is evident. The only flip side is that sometimes the signals aren't great. On the bottom of the cliff, for example, might not be pointing the right direction, but we have found it to be quite okay. I mean, you mentioned the mountains earlier on. We have another application in the Wicklow Mountains, and even though we don't get mobile coverage, we actually do get IoT coverage, which is interesting. So you can get these signals even where you don't expect it. That's it. There's an example of them there. So that particular sensor measures distance, so it can be used on lots of different types of cases. So, energy monitoring was the last one I'll go into detail. This is unlike the other ones. We've used Sigfox NB-IoT LoRa as well. But this one here is actually it's Wi-Fi. It's internal to a building, but it's still technically IoT because it's just sending data to the cloud. You've developed your own monitor. This was done under one of our European projects, and basically measures power. It's monitoring the energy consumption in a house, and it actually has a sub. It's not written there, but it has a sub LoRa function. You have another board inside that has LoRa on it, but LoRa Phi they call it. It's a local LoRa that talks to other devices around the house and collects that data, aggregates it all, and sends it up together. So we're actively developing that thing all the time. So it's a low-cost way of getting the data. I mean, the case for that has been made a long time ago. It's long gone as the time for the meter man goes around and reads the meter. It's almost all done that way at the moment. Anyway, what's driving this is, I'm sure that councils have seen this. There's a European directive on energy performance that's come into force, and it's forcing more and more monitoring at lower and lower levels, even individual houses. I don't mean for billing, but just for improving energy efficiency and so on, and improvements. Let's see here, and this is an example of some graphs that times of the year, some data that you see on there on the left, typical information you get. So other applications, I just throw them out there. Some of these have been mentioned already. Bidirectional signaling. Most IoT that we've been talking about today is one direction, where you're sending the temperature up, or the count of the number of people, or the water levels. Typically, is one direction. But sometimes you want to control something. So we have one application actually is in the mountains there in Wicklow, where we're actually controlling a light and checking that the light's actually on. So it's bidirectional. That's done by IoT. We have an box on the bottom right is an emergency light. Emergency lights have to be legally checked every month or every 3 months or something by. Not that many people do that, but that's I believe the regulation. So we work with the company to develop an NB-IoT-based solution that does that system automatically. As soil moisture was mentioned, we're doing that. Also, another project we're working on is detecting the advancement of crack in a structure, a concrete structure, to see how it progresses over time. Again, that's an expensive process. You send an engineer out normally every 3 months or whatever, and he measures the number of millimeters that a crack is. So that, depending on where that structure is, that can be a really expensive site code. You know, having an IoT solution for that makes it much easier to integrate. Level monitoring, we mentioned that already. Again, people come to us all the time with problems, and we look at how to do that. So again, our work is literally on the cold face, trying to figure out how to measure these things. Just the broader relevance here. There's only 2 or 3 slides more. Yeah, these sensors complement, they don't replace anything, they complement the activities of other people out there, whether it's somebody collecting bins or planning the number of waste bins required for the next year or whatever. So it's a complementary thing. So there can be, but there's the range of skills. Well, the users can be at the very high end, the planning type people, to the people on the ground actually using the app. And it's quite a wide range. And it's sometimes we find that it's hard to get the balance right. It depends on who you're trying to design this for. So, for example, if somebody's out there emptying bins, you can't expect them to be taking their gloves off and coming onto the app every 2 minutes. So there are practical problems as well. So we've got to work through these things all the time. So, again, if you have an idea for an IoT project and you don't know how to go about it, we propose, identify an application, maybe on some other trip, somewhere else, establish the objectives, what you're trying to do here, and what the economic objective is as well. And design a trial. Don't start with millions. I'll just do a trial, like what you've been doing, I suppose, and maybe combine that with some virtual monitors. Not every single thing has to be monitored. But bring all the data together in one place. Deploy a set of monitors and see how it goes. So anyway, that's my 2 cents worth. Hope that was interesting. Take a roll. Okay.
Thank you very much, Kieran. Very interesting. I think even if we have gone over time, I think it was really worth to listen to all the speakers. I want to thank you all. Also apologize for pushing you a little bit on the time, but maybe we can dedicate 5 minutes for questions if we have some questions, either coming from the people that was connected online or here. So, Margaret, I don't know if we have any questions.
Not yet, but I'm just asking people to.
Okay, if not, if anybody here also wants to make any question. Yeah. Otherwise, while we are waiting for questions, if not, we can close here. Again, I want to really thank the speakers and understand this event is being recorded, so will be available also and accessible in the Data2Sustain website. Also, if you have interest, more questions, please stay in touch to us also through Data2Sustain, and we will also can direct your questions to our speakers today. Yes. Okay, yes, Margaret is there. So,
I just wanted to ask one question to Kieran. So, your customers, are they all in Ireland? Is it mostly the councils?
Oh, yeah, mostly in Ireland. We're getting federal requires, especially the governing ones are from other countries, but the main ones are in Ireland, yeah, councils and so on, yeah. We have other business for other products for other countries, but for the IoT sensors, generally speaking, it's in Ireland.
And I have one question about, say, just for like, for example, the funds. Would you have any data about, say, for a particular collection fund?
Excuse me?
Would you have any data, say, for bond collection fund on savings and savings that have been made?
On savings back.
Yeah,
Uh,
from implementing the sensors.
on what application? The bins, is it?
Say, for example, the bonds, I assume that's Northern Ireland, because the bonds are privatised in the public.
The bins, well, it's South Dublin County Council we work with on that. So
Yeah.
I've asked that. It's an ongoing debate with them, but we've seen. I forget the actual numbers, but I think it was on the order of 30% or so. And it wasn't the whole lot. It was only a pilot trial.
Yeah. Right, so 30% is a lot.
Yeah, together it's limited to maybe a route of about 110 bins. So
Yeah.
I can talk directly about that. And
Okay. Any other questions? Anything in the chat? No? Okay, so maybe we can.
Hello.
Maybe we can. Yes.
Sorry, I'm just wondering, have you had any interest from Irish Water in relation to some of these sensors?
we haven't no. We haven't contacted them either. So we haven't had.
We had some discussions with Irish Water a few years ago. They're quite conservative in their adoption of technology, so they want to see it proved out before they will actually begin to do a pilot. Yes, it's just quite difficult to work with them.
I think their big thing is leak detection, and that's the thing they're trying to find out. So,
Okay. That's
I
fine.
think that's Sean. Sean, Stephen,
Yes.
Seawright here. Yeah, just wondering what technology do you use for the mesh that you mentioned? Is it Bluetooth or BLE?
It's a Sigfox based system.
No, the mesh part. You mentioned that the lighting is on mesh.
It's a mesh system, yeah, utilizing Sigfox.
Okay. Any other questions, or should we finish here? Okay, so again, thank you very much to everybody here in the room, also the ones that you are online. I don't want also to forget to really thank also my colleagues, Margaret, that was putting all this good agenda here, my colleague Maisa helping with all the communications and the technical stuff, and also my colleague Mario with the logistics. So thank you very much, everybody. Have a nice day, and please stay in touch if you are interested in this topic. Bye, everybody. Thank you.
Thank you.
Thank you. Bye bye.